Alright, welcome back everybody. In this video we're going to look at our final three indeterminate forms and how we're going to use L'Hopital's rule to find the values of these. And these are limits that when we try to evaluate the limit, they end up either in the form 1, something approaching 1 to something approaching infinity, or something approaching 0 to something approaching 0, or something approaching infinity raised to something approaching 0. And we're going to handle all three of these in pretty much the same way, utilizing the fact that the natural logarithm and the natural exponential are inverses of one another. We can turn all of these expressions into limits that we can find using L'Hopital's rule. So first we're going to find the limit as x goes to infinity of the quantity 1 plus 1 over x raised to the x. And what happens in this limit is as x approaches infinity, the 1 over x approaches 0. So what's inside the parentheses approaches 1, and the exponent approaches infinity. And here's how we're going to handle this. We're going to take this limit and take e to the natural logarithm of this limit. Alright, now we're going to utilize the fact that the natural logarithm of a limit is equal to the limit of the natural logarithm of that expression. And so this is going to be equal to e to the limit as x goes to infinity of natural log of the quantity 1 plus 1 over x to x. I like to say that, the log of the limit is the limit of the log. It's very sing-songy and kind of helps remind me what's going on there. Alright, and now since I have this natural logarithm, I can apply natural logarithm properties inside of my logarithm. And this turns into the limit of x times the natural log of 1 plus 1 over x. And now what's inside of my limit is something of the form infinity times 0. And so I can apply L'Hopital's rule on this particular limit by turning it into something of either the form 0 over 0 or infinity over infinity. In this case, it will turn into natural log of the quantity 1 plus 1 over x all over 1 over x. And now I can apply L'Hopital's rule. Notice that this whole time, this limit is e is in the exponent of a natural exponential. And so now I'm going to take use L'Hopital's rule here. And so the derivative of the numerator turns into 1 over 1 plus 1 over x times the derivative of the inside using the chain rule, which is negative 1 over x squared, all over the derivative of the denominator, which is negative 1 over x squared. And now, these negative 1 over x squareds I can cancel out and simplify what's inside that limit. And that turns into e to the limit as x goes to infinity of 1 over 1 plus 1 over x. Now taking the limit of that, as x goes to infinity, 1 over x goes to 0, and so this just turns into e to the first power, or e. And so our limit as x goes to infinity of quantity 1 plus 1 over x to the x is equal to e. And this should be kind of familiar to you because, quite frankly, this was how you were introduced to the concept of e in pre-calculus. You looked at the function 1 plus 1 over x raised to the x power as x got bigger and bigger. You didn't really talk about it as a limit at that point in time, but nonetheless, it should make a lot of sense based on that previous knowledge. Alright, next form 0 to the 0. And if you look at the limit that we're taking, we've got the limit as x approaches 0 from the right of the quantity sine of x raised to the x power. And that, again, is the form 0 over 0. So we're going to do exactly what we did in the last one. We're going to take e to the natural log of this limit. And the whole basic concept here is that we're doing this because taking the natural log of what's inside of the limit enables us to get that exponent, off of the expression. And so we proceed thusly. And so we bring the x, excuse me, we bring the x out in front. This turns into x times the natural log of sine of x, which is something of the form 0 times infinity, because as x approaches 0, the sine of x approaches 0, and as that approaches 0, the natural log approaches negative infinity. And so now we're going to convert it over into something that we can use L'Hopital's rule on. And then I'm going to, since I can't really do anything with the natural log of the sine as far as simplification, I'm going to bring 1 over x into the denominator, since that's the same thing as multiplying by x. And now we have something that goes to infinity over something that goes to infinity, and we'll apply L'Hopital's rule. And so we've got 1 over sine of x times the derivative of sine of x all over negative 1 over x squared. It's probably a good idea here for us to simplify this before we try and do anything else as far as evaluation goes. We've got e to the limit as x goes to 0 to the right of the opposite of cosine of x all over x squared sine of x. Alright. No, it's not. The x squared goes with the cosine. Oh, geez, Thomas. And now this turns into something of the form 0 over 0. So we need to apply L'Hopital's rule again. And we've got negative x squared times this derivative of cosine, which is negative sine, so that's x squared sine of x, plus cosine times the derivative of negative x squared, so that's minus 2x cosine of x. All of that over cosine of x. And as as x goes to 0, this is going to be e to the 0 minus 0 all over 1. So it becomes e to the 0, which is 1. And so that's the limit of our original expression. It's 1. One more. The form infinity to the 0, and that's what we have here. We have something going to infinity being raised to something approaching the 0 power. Again, I'm going to set up e to the natural log of this limit. And then the log of the limit is the limit of the log. So this becomes e to the limit as x goes to infinity of natural log of x to the 1 over x. I use logarithm rules to bring out the exponent. And then I want to turn this into something of the form infinity over infinity, or 0 over 0. It's very easy. I just write it as a single fraction. And now I can apply L'Hopital's rule. And so I'll take the derivative of the numerator over the derivative of the denominator. Simplify that a little bit. And now as x goes to infinity, 1 over x goes to 0, so this is going to be e to the 0 or 1 as our limit. Okay, and that's how we can use L'Hopital's rule on the indeterminate forms dealing with exponents. We can set up this e to the natural logarithm every time, take the exponent out, and then use things that we've already learned about how to manipulate and use L'Hopital's rule in order to find those limits. Alright, that's the end of this video and the end of our discussion of L'Hopital's rule. See you guys. Have a great rest of your day.